Welcome to MarkScheme, the Binomial Theorem. Everything you need made visual. Suppose I ask you to expand a plus b, all to the power 5. The brute force way is to write out 5 brackets and multiply them together. Slow and a nightmare to keep track of. But there's a shortcut so clean, you can write the answer straight down. It comes from a triangle of numbers. And by the end of this video, you'll expand any bracket like this in seconds. Pull out a single term without expanding at all. Find the constant term, and even run the whole thing backwards to find the missing power. Here's exactly what this covers, straight from your syllabus. Analysis and approaches, standard level 1.9. Pascal's triangle, combinations, and choose R, and the counting idea behind them. Expanding a plus b to the power n, where n is a positive whole number. And finding one particular term, or coefficient. Tick all 4, and the subtopic is complete. And, just as important, what you do not need. Higher level extends this to fractional and negative powers of the bracket, and to permutations, NPR. Those are not on your standard level paper, so we'll leave them out. At SL, the power n is always a positive whole number. Before any clever shortcut, let's just do it by hand, on a small case, so the pattern reveals itself. A plus b squared is a plus b times a plus b. Multiply out. A squared plus ab plus ba plus b squared. The two middle terms are the same, so they collect into 2ab. The coefficients are 1, 2, 1. Multiply once more for the cube, and after collecting like terms, you get a cubed, plus 3, a squared b, plus 3, ab squared, plus b cubed. Now the coefficients are 1, 3, 3, 1. Notice two things. The coefficients are symmetric, and each set, 1 to 1, then 1, 3, 3, 1, looks like the next line of some growing triangle. It is. That triangle is the shortcut. Meet Pascal's triangle. The rule is dead simple. Start with a single 1 at the top. Every row begins and ends with a 1. And every other entry is just the sum of the two numbers directly above it. Watch it build. Row 2, 1's on the ends, and in the middle, 1 plus 1 is 2. Row 3, 1 plus 2 gives 3, and by symmetry, 3 again. Row 4 now. The ends are 1. The next entries are 1 plus 3. That's 4 on each side, and the very middle is 3 plus 3, 6. Then row 5 falls out the same way. 1, 5, 10, 10, 5, 1. And there's our by hand result sitting right there. Row 2 is 1, 2, 1. The coefficients of a plus b squared, and row 3 is 1, 3, 3, 1, the cube. The triangle is just remembering the pattern for us. Now the magic. Each row of this triangle is a set of coefficients for a binomial expansion. Row 4, 1, 4, 6, 4, 1 gives the coefficients of a plus b to the power 4. Watch these 5 numbers fly down and slot straight in front of the powers of a and b. Those triangle entries have a proper name, combinations. NA choose R, written NCR, or as a number stacked over another in brackets, counts the number of ways to choose R objects from n when the order doesn't matter. The formula is n factorial over r factorial times n minus r factorial. It's in your formula booklet, and your calculator has a button for it. Let's check one. 4 choose 2 is 4 factorial over 2 factorial 2 factorial. 24 over 4, which is 6. And look, that is exactly the middle of row 4. In fact, the whole of row 4 is 4 true, choose 0 up to 4, choose 4. 1, 4, 6, 4, 1. Pascal's triangle is just a table of combinations. One neat fact worth pocketing. N choose R equals N choose N minus R. Choosing which R to include is the same as choosing which ones to leave out. That symmetry is exactly why every row of the triangle reads the same forwards and backwards. Here's the real reason the combinations show up. And it's the deepest idea in the whole topic. Expanding a plus b cubed means picking one term, either a or b, from each of the three brackets, and multiplying your choices. There are 2 choices per bracket. So 2 times 2 times 2, 8 possible products in total. Now group them. To land on a squared b, you need exactly one b, and it can come from any one of the 3 brackets. That's 3 choose 1, which is 3 ways. To get a b squared, you pick which 2 brackets give the b. 3 choose 2, again 3. All a's is one way, all b's is one way. So the coefficient of each term is simply the number of ways to choose which brackets hand over a b. And that count isn't choose R. The triangle wasn't a coincidence. It was counting all along. We can now write the whole thing in one line. The binomial theorem. A plus b to the power, n equals the sum, as r runs from 0 to n, of n choose r, times a to the n minus r, times b to the r. Every piece of that we've now earned. The n choose r is the counting coefficient, and the powers split the n between a and b. Write out a plus b to the 4, term by term. The coefficients are the combinations. Our row 4, 1, 4, 6, 4, 1. Now watch the powers. The power of a starts at 4 and falls. 4, 3, 2, 1, 0. The power of b does the opposite. It climbs from 0 up to 4. And here's the check that saves you every time. In every single term, the 2 powers add up to n. 4 plus 0, 3 plus 1, 2 plus 2, 1 plus 3, 0 plus 4, all equal 4. If a term's exponents don't sum to n, you've made a slip. Let's warm up with the friendliest case. Expand x plus 1, all to the 4. Set the equals x and b equals 1. Because every power of 1 is just 1, the b's vanish. And the expansion is nothing more than row 4, glued onto falling powers of x. So x plus 1 to the 4 is x to the 4 plus 4x cubed plus 6x squared plus 4x plus 1. The coefficients 1, 4, 6, 4. 1 are read straight off the triangle. Whenever the bracket is x plus 1, the row is the answer. A lovely sanity check to memorize. Now a proper one. Expand x plus 2, all to the 4. Set the equals x, b equals 2. Lay down the coefficients from row 4 and attach falling powers of x with rising powers of 2. And remember to raise the whole, 2. So 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16. Multiply each combination by that power of 2. 1, then 4 times 2 is 8, 6 times 4 is 24, 4 times 8 is 32, and 1 times 16. So x plus 2 to the 4 is x to the 4, plus 8x cubed, plus 24x squared, plus 32x, plus 16. Here's the edge case. Examiners love. Change the plus to a minus. Everything is identical except the sign. Because b is now minus 2, the odd powers of b turn negative. so the signs alternate. Plus, minus, plus, minus, plus. Same numbers, flipped signs. Miss that, and you lose easy marks. Very often, the exam doesn't want the whole expansion, just one term or one coefficient. Expanding everything wastes time. Instead, use the general term. Term number r, plus 1 is n, choose r, times a to the n minus r, times b to the r. Choose r to hit the power you're after, and compute only that single term. Find the term in x cubed in 2x minus 3, all to the 5. Here a is 2x, and b is minus 3. The general term is 5 choose r, times 2x to the 5 minus r, times minus 3 to the r. I want x cubed, and the x lives inside the 2x part. So 5 minus r must equal 3, giving r equals 2. Sub that in, 5 choose c, 2 is 10. 2x cubed is 8x cubed, and minus 3 squared is positive 9. 10 times 8 times 9 is 720. The term is 720x cubed. And I never expanded the whole bracket. Now a tougher exam favorite, the constant term. Expand 2x minus 1 over x, all to the 6, and find the term with no x at all. This still lives inside our syllabus. The power 6 is a positive whole number. But the two parts now carry opposite powers of x, so they can cancel. Write the general term. 6 choose r, times 2x to the 6 minus r, times minus 1 over x to the r. Collect the powers of x. From the 2x part, you get x to the 6 minus r. From the 1 over x part, you get x to the minus r. Add the exponents, 6 minus 2er. For a constant, that exponent must be 0. So 6 minus 2r equals 0. Given r equals 3. Put r equals 3 back in. 6 choose 3 is 20, 2 cubed is 8, and minus 1 cubed is minus 1. 20 times 8 times minus 1 is minus 160. So the constant term is minus 160. And notice the sign came from that odd power of a negative. That's the whole game. Match the powers to kill the x. Then compute the one term. Last one, and it runs the machine in reverse. We're told the coefficient of x squared in 1 plus x to the n is 15, and asked to find n itself. Start with the general term for 1 plus x to the n. Since a is 1, every power of a is 1. So the term is simply n choose re times ag to the r. For x squared, r is 2. So the coefficient is n choose 2. Set that equal to 15. Now n choose times 2 is n times n minus 1 over 2. So n times n minus 1 is 30. That rearranges into a quadratic. N squared minus n minus 30 equals 0. Factorize. N minus 6 times n plus 5 equals 0. So n is 6 or minus 5. But n counts brackets. It must be a positive whole number. So we throw out minus 5 and keep n equals 6. Working backward like this, spotting that a coefficient hides a small quadratic in n, is a classic harder paper move. Now the exam craft. 5 things that separate full marks from nearly. First, your calculator has an NCR command. Type 5 NCR 2 and get 10. A whole row of Pascal's triangle is just those combinations, so you can check any row instantly. Second, the shortcut we leaned on. For the term in x to some power, or the constant term, set the total power of x equal to what you want and solve for r. Don't expand everything. Third, raise the whole part. 2x cubed is 8x cubed. Minus 3 squared is positive 9. The number inside gets the power as well. Fourth, the powers of the two parts always add to n. a 1-second sanity check, and when the bracket is a minus b, the signs alternate. And fifth, earn the method marks. State the general term. Show which error you choose, then compute. And on paper 1, leave exact integers, never rounded decimals. Finally, the 4 traps. 1. Writing a to the n minus r, b to the r, but forgetting the n, choose r in front. The coefficient is not optional. 2. Power bookkeeping. 2x all cubed is 8x cubed, not 2x cubed. Raise the whole part, its number included. 3. Sign errors. Minus 3 squared is positive. 9, not minus 9, but minus 3, cubed stays negative. And 4, the sneaky one. The general term tr plus 1 uses the power r. So the fourth term has r equals 3, not 4. Mixing up the term number with r is a constant source of lost marks. Dodge these, and the binomial theorem is free marks. And that's SL 1.9, fully covered. Pascal's triangle, n, choose r, the expansion of a plus b to the n. Finding a single term, the constant term, and even working backwards to find n. And with that, topic 1, number and algebra, is complete. Every subtopic from 1.1 through 1.9, done. Next, the course moves into topic 2, functions, starting with straight lines. For more, that's markscheme.app. See you in topic 2.